Ngamalolesha the way our mapping was done. Okay, the way our mapping was done, you'd notice that Monsomu, we've kind of just used memory bit addresses. Okay, we've not used the physical input and output addresses, which presents a problem because nga mudatwala ndile padi factory IO, that factory IO ile sumina fiama physical input and output module addresses by way of I 1.0, Q 4.0 and whatnot. Okay, so for us to be able to get inputs for the simulation, to allow the map all these inputs which were identified as inputs and those which were identified as outputs, we're going to map them to actual physical input and output addresses. And to help us do this, the interesting bit is we're going to look at the hardware configuration. Ngamuda tuachitile configure. So mwala mwanati that was some of the hardware configuration. So I am input modules. We had mudi hardware configuration. Tualikwetama digital input modules, tuakwatana digital output module imo. So apapa kushitama ama inputs because we identified that not quite ordinary input signals to quite an area input signals are associated na protection functions such as emergency push patterns, the thermal overload, the earth leakage protection, and the emergency push patterns. Okay, those we identified as being among the protection inputs. So to allow to separate, okay, I am my input modules. So to help us with this, to allow that the first input module move slot 4, we're going to add a comment, okay, which is to say this particular module, we're going to say module for operational inputs. Okay, input operational input addresses only. Okay, and then in slot 6 we're going to say protection input module. Which is to say that yon some input signals associated with a protection function, we are going to assign to them addresses in the range of input module slot 6. So for protection inputs, the addresses will range from input 5.0 all the way to input 6.7. So these are going to have a specific input module. Okay, and then for those ordinary input signals, start, stop, reset, those are going to be associated with the input module in the slot 4 position. And then of course we could extend these signals to the input module in slot 5 if we wanted. Okay, so having said this, what we're going to do is we're going to close this, but of course we need to save. And then what we're going to do is we're going to open Excel, and then remember that symbolic table we exported to the data interchange file format. Okay, so we're going to open that file. Okay, we're going to open it, and I've saved it by desktop, so just going to go there, all files, then we're going to open this. Okay, so when it does open, this is basically just the same symbolic table but exported to Excel. And the reason why I've done this is the following. Okay, move or copy. I know I'm going to have to delete this other one. So what I'm going to do is I'm just interested in the inputs. Okay, I'm just interested in the inputs. Olonga mwaibu kisha the way we did our address assignment. We know that Yonsama memory bits associated with memory bit 10.0 all the way to memory bit 11.3, these are just ordinary inputs. Okay, by just looking at them: system start, stop, main drive circuit breaker, normally open auxiliary contact, and then lubrication pump normal select, lubrication pump off select, lubrication pump test select, lubrication pump test push button, system reset, and whatnot. So these are just normal inputs. And then if you look at the addresses in the memory bit 20.0 range, meaning these ones here, okay, these are protection inputs. Okay, these are protection inputs. And then for the outputs, we just need to identify those which are going to have control external to the PLC. Okay, and I know for a fact that we're talking about the pre-start warning alarms. Okay, these are going to have external control because this is the pre-start warning siren in both the local and remote stations. So these are actually going to have devices outside of the PLC. And then of course, in Shibati, I would also need the lubrication pump. Okay, I would also need the lubrication pump by way of lubrication pump control, which is 4DC1. And then we would also need the main drive. Okay, main drive control, which is this one here. Okay, if you have got a assignment to the output module, all these are highlighted moody green, meaning these are actual physical outputs: the pre-start warning sirens, and then the lubrication pump control, and then the main drive control. Okay, and then what else do we need? Okay, so we're going to have these. Do we need AMA indicator lamps? Loop pump running, lubrication pump status running. So lubrication pump status faulted or healthy, lubrication pump what is this now? Lubrication pump status faulted. Okay, 4DD1 and 4DH1. I think the one we need is the indication one. Okay, and then what else? Lubrication pump status running. Even this is going to have a physical unit to be controlled outside of the PLC environment. External, meaning these are going to be loads. Okay, and then lubrication oil temperature high. Lubrication oil temperature high indication. It's a physical indicator. Okay, lube oil flow, lubrication oil flow stopped indicator, meaning even this one here. And then lube oil filter blocked. Because I believe even this can be a physical indicator light or lamp. So main drive status faulted or healthy. Okay, and then main drive test mode. Okay, so main drive status faulted indication. Okay, this is an indicator lamp. And then the crusher running indication, it's an indicator lamp. Okay, so I think this pretty much covers all the necessary input conditions where we need to, or rather the necessary input and output conditions for which we need to assign the module addresses by way of those physical input addresses. Okay, so what we're going to do is, okay, let me get rid of this. Don't worry about it. We're not really going to have issues with this. I just want to get rid of those which for now we haven't identified as actual physical inputs or actual physical outputs. Okay, so I'm just going to delete this like so. Right in, let's delete this. Okay, now that we've done this, okay, now that we've got this done, what we're going to do is I'm going to insert another column. Okay, I'm going to insert another column. I'm going to insert this like so. I'm going to insert a column like so. And then what we're going to do with this is the following. Okay, remember our reference point is going to be what we mentioned here in the hardware catalog, or rather in the hardware configuration. Okay, what we did say in the hardware configuration, that ordinary inputs are going to start from address I1.0 all the way to I4.7. Okay, having said that, what would happen now is the following, that we can start with input I1.0. Okay, let's see if we can just drag this. Okay, 1.5, 1.6, 1.7, then I2.0, 2.1, 2.3, okay, 2.0, 2.1, 2.2, 2.3, and then when we come to the protection inputs, okay, for the protection inputs again, you'd notice that we'd resolve to start from input 4.0, or rather 5.0 for protection. So in this protection input module, okay, meaning that we've dedicated the input module in slot 6 to be specifically for those inputs we consider to be related to the protection function. So we're going to start from input 5.0 all the way to input 6.7. Okay, so we come back here, we say input 5.0, input 5.7. Okay, let me just drag this now. No, what are you doing? 5.0 input 5.1. Okay, input 5.6, then input 5.7. okay, then it goes without saying input 6.0, input 6.1. You can just stretch this like so, and then for the outputs, okay, we'd resolve to start our output addressing from Q4.0, okay, because the output module is in slot 7, so the first output address is going to be Q4.0. okay, so we're going to say Q4.0, say Q4.0 as the first output address, Q4.1, then we're just going to drag this all the way down. Okay, 4.5, 4.6, 4.7, and then Q5.0, Q5.1, Q5.2. okay, so basically now this takes care of the address assignment. But now you do realize that these symbolic names are already assigned to these memory bit addresses. So the only thing I can do is I'm going to just specify that I'm talking about peripheral inputs. Okay, I'm just basically talking about peripheral inputs. So I'm going to copy this, then I'm just going to add peripheral input to each and every symbolic name. Okay, and I'm sure there are a lot of other ways you can do this, but I'm just going to use the same symbolic names, but make it clear that this address is supposed to be mapped to a physical input module or physical output module. Okay, so peripheral means external to the PLC. It's a peripheral input in the sense that this address is pointing to an actual physical unit. Okay, so there we go, like so. And then the ones highlighted in green are peripheral outputs. Okay, so these are going to be peripheral outputs, as in PO, peripheral output. Control C, Control V, okay, just so tamuluvire, the only thing I'm trying to tell you is these input 1.0, input 1.1 and whatnot, Q4.0, Q4.1, these are like controlling or receiving inputs from those, or rather they are receiving inputs from a peripheral device like a start push pattern, which is why I'm saying this system start PI. I'm just saying the input signal at this address input 1.0 is coming from a physical device. Okay, and the reason I'm just adding PI is because I've designed a whole program using memory bits, okay, which already have these names already assigned. So we can't have two different addresses with the same symbolic identifier. Okay, it doesn't really work like that. So that's done. And then when I do this, the only thing I'm going to do is I'm going to delete the memory bit addresses. Okay, like so. No, I don't want to save this. So because I really need to import this file back into semantic step 7, okay, as a symbol table, right? So the only thing I can do now is I'm going to copy everything like so. I'm going to copy everything. I'm going to copy everything like so. Then I'm going to go to the first file, and then I'm going to add them right about here. I think we're going to go like this, okay, and then I'm going to delete the second file. Okay, I just used it to just sort out the addresses. Okay, so having done this, I believe we can save this. Okay, we're going to save this. Just say yes, then let's close this. Yes, I need to. Do you want to save the changes you have made to plant004.dif? Yes, I need to save this. Yes, please. Okay, so now that is done, so I'm going to come back to my project file, plant004, and then I'm going to find where the symbolic table is. Should be in here. Oh no, should be, where's that? Symbols. Okay, I'm going to delete this. I'm going to delete this file. Okay, inside objects. Okay, do I need to import? Okay, if I say symbol table, no, I don't need to do this. Okay, a blank symbol table, and then I'm going to say symbol table import. Then that file was saved on the desktop. Okay, which is all files. Oh, okay, I need to open this. Yes, I know the consequences. Okay, like so. So let's see, are we good to go? Okay, so I think we're set, as in all the edits have been like imported into our symbolic table for the project. Okay, so now we go back to input mapping. What it is now we're going to go to the inputs. Okay, okay, because these are not no longer in sequence. So let's see. 3bh1, is this a good thing or a bad thing? Because we could easily end up missing some addresses. Okay, so we're going to start from system start. Okay, so we're going to get this, and system start is equal to what? Is equal to this address. Okay, is equal to the memory bit address for system start. Okay, so we're going to have that, and then the next one is system stop, this address. Okay, system stop is equal to this address, system stop. Okay, maybe you can leave a bit of space there. The third address is what? 1.1, 1.2 is main contact, main drive circuit breaker, normally open auxiliary contact. So get this one here, MC, okay, which is right about this one here. Okay, and then input 1.3. okay, let me just do this, okay, because this is pretty much going to be okay. Input 1.3, lubrication pump normal select. So we'll come here, lubrication pump normal select, peripheral input. So this address, okay, is equal to this one here, and then 1.4, lubrication pump is equal to this one here, and then 1.5, is lubrication pump test, it's this one here, and then 1.6, ten point 10.6, right? And then 1.7, yeah, 1.7, One 10.7. Okay. Huh. 10.7, and then we have 2.0. Okay. Oh, I wish we could we just copy this? I don't know. Okay, maybe I'll just do it like this, and then 2. and then this is MDNS. I need to copy all of these up to here. Okay, up to there. Is equal to okay. Okay. So the only thing I'm doing is I'm just doing the same thing we've already looked at, okay? And you've seen me explain how we've chosen to assign these addresses. So now I'm just going through the motions of trying to map the addresses so that the whole thing works as a unit, okay? So I'm not really doing anything extraordinary, okay, or something that you wouldn't really understand. Okay. And there's the last one. Okay, so basically that takes care of the inputs. Okay, so we can do the same thing for outputs. Okay, so this one here is input mapping, and then we'll add another network, or rather insert a network to view. Then this one is going to be output mapping. Okay, so for outputs we're talking about the hundreds. Okay, we're talking about the hundreds. So which ones do we have? We had these ones right here. Okay, I'm just going to copy them and paste them there. Okay, so the first one is pre-start warning. Okay, this is going to be okay. Maybe let's arrange them by symbol. Let's see if this helps our case. 281 main drive control, so we're talking about Q4.0. okay, Q4.0 is which one now? 222. Okay, if I go by symbolic name, does this help my case? So Q4.0 is this one here, pre-start warning. So essentially we're talking about this one here, and this is assigned to this. Okay, Q4.0. Need this one here. Then Q4.1 is what? Q4.1 is this one here. Preset warning, siren, remote station. I'm looking for this address. So, and this one here is equal to this one here. Okay. And then Q4.2 is going to be this one right about there. 4DC1 peripheral output 4DC1. So I'm looking for this one here. So I'm going to say and Control V is equal to this. Okay. Q4.3 is maybe down. Nope. Q4.3. Okay, I know for a fact I'm going to be looking for Q4.3. So Q4.3 is what am I not seeing? Q4.3, 4.1, 4.0. Q4.3 is right about here. Is 4DH1 peripheral output, and then 4DH1 is the equivalent memory bit address. So I'm going to get this one here. I'm going to say and Control V, then assign it to this physical output address. And then Q4.4, I saw it right about there, is 4DH2. Yes, I'm looking for this address right about there. And then we want to do this. And then Q4.5 is where now? Is right about there, 3BH1. I'm looking for this address here. So assign to this one here. And then 4.6, Q4.6. Looking for this one here. Is equal to this one here. And then I'm looking for 4.7, Q4.7, 3BH3. Looking for this one here. And then it's assigned to Q4.7, okay. And then 5.0, 5.2, I see you. 5.0, I'm looking for 281, okay. 281 is assigned to this one. It's 281 peripheral output, okay. Then we're looking for Q5.1, which is this one here, and I'm looking for 2AH1, okay. 2AH1, 2AH1, okay. And then 5.2, okay, 5.2, Q5.2 is 2AH2. So peripheral output 2AH2 peripheral output is assigned to address Q5.2, and the memory bit address equivalent, okay, is supposed to be 2AH2, okay. So, and is assigned to this one here, okay. I think basically that pretty much takes care of the entire map, okay. So in the next section, we're going to see how we can now improve on what it is we have done by making use of input validation, making use of this function. So that's what we're going to look at in the next section. I hope you join me for that. So cheers.